Welcome back to the Deep Dive, the show where we navigate the sprawling ocean of information, extracting those invaluable insights and transformative nuggets of knowledge you need to be truly well-informed without the constant overwhelm. Today we're embarking on a crucial deep dive into a methodology that's not just critical, but genuinely revolutionary for modern technology, DevOps. Our focus comes from a comprehensive body of sources, specifically what we've titled Embracing DevOps, Bridging the Gap Between Development and Operations. This isn't really about code or servers. It's a profound rethinking of how we collaborate, innovate, and deliver value in the digital age.
And that's exactly where it gets so fascinating. DevOps transcends purely technical boundaries. While its roots are firmly in software development and IT operations, the core principles we'll explore today, things like collaboration, automation, continuous improvement, shared responsibility. They actually offer a blueprint for optimizing how any complex team or organization functions, well beyond the data center. It's kind of a holistic philosophy disguised as a tech buzzword.
That's a fantastic way to put it. So for you, our listener, why should DevOps capture your attention in today's relentlessly accelerating tech landscape? Well, despite the hype, it truly is essential. It's the engine driving faster software delivery, bolstering quality, and perhaps most importantly, radically enhancing team collaboration and satisfaction. The fundamental problem DevOps sets out to dismantle is those entrenched, often dysfunctional silos that traditionally separated development and operations teams, replacing them with a vibrant culture of genuine shared responsibility.
Indeed. And if we connect this to the bigger picture, you consider that market demands are shifting at just an unprecedented pace. Organizations simply cannot afford the luxury of slow, disjointed processes anymore. DevOps provides a robust framework for achieving the kind of agility and responsiveness that's no longer just a competitive edge, but a sheer requirement for survival and growth. Our mission today is to illuminate its key principles, dissect its profound impact on team dynamics, both the breakthroughs and, the inherent challenges, and distill practical, actionable strategies for technical management to effectively champion and lead this vital cultural shift.
And our promise to you, the learner, is that this deep dive is designed to empower both developers on the front lines and managers shaping strategy to truly grasp this game-changing methodology. It's about more than just understanding the jargon. It's about unlocking better organizational outcomes, fostering happier teams, and building a more resilient, innovative future. Get ready for some surprising facts, a few aha moments, and hopefully a fresh perspective on how modern work gets done. Okay, let's unpack this. What exactly is DevOps, and what frustrated past did it emerge from? The genesis of a movement, understanding DevOps' origins. To truly appreciate DevOps, we have to rewind a bit, journeying back to a time many of us probably remember all too well. DevOps didn't just appear out of thin air. It was like a desperate solution born from very real, very widespread frustrations that have been simmering in the tech world for decades. It was sort of a pressure cooker building up to a breakthrough.
That's precisely it. And what's fascinating here is that the historical context isn't just background noise. It perfectly illustrates the profound necessity for a new approach. Before DevOps began taking shape around, 2007, 2008, the relationship between development teams, who were tasked with building the software, and operations teams responsible for deploying, maintaining, ensuring stability in production. Well, it was often defined by tension and conflict. Imagine a constant cycle of blame and, frankly, gross inefficiencies. Developers would build a new feature or fix a bug, test it rigorously in their own isolated development environment.
Right, their little bubble.
Exactly. And then, in what became known as throwing it over the wall, they'd hand it off to operations with the infamous declaration, "It works on my machine." Now, this wasn't a malicious statement. It reflected a genuine truth within their controlled bubble.
Sure, it worked there.
But then, operations would take that code, attempt to deploy it into a vastly different production environment, maybe different server configurations, network settings, even missing dependencies, and inevitably, issues would arise. Things would break.
Of course.
And their response would often be, "This isn't production ready. Your code is unstable." This finger-pointing wasn't just unproductive. It led to excruciatingly slow delivery times, persistent bottlenecks, and a colossal amount of wasted effort. Not to mention a significant toll on the morale and stress levels of everyone involved. It was a classic us versus them scenario,
Yeah.
Each team had its own distinct goals, often perceived as being at odds with the others. Developers prioritized rapid feature delivery, while operations focused on stability and uptime, creating this fundamental tension.
That sounds like a truly demoralizing way to work, for sure. And this kind of friction really highlights the limitations of the older, software development models, doesn't it? Particularly that rigid waterfall model that so many organizations clung to for far too long.
Absolutely. The waterfall model was characterized by its highly linear and sequential nature. You'd complete one phase like requirements gathering before moving entirely to the next, like design, then implementation, testing, and finally deployment.
Very step by step.
Very step by step. And there was very little feedback or iteration allowed between these stages. The consequence: problems discovered late in the process, especially during operations or deployment, often meant a full or partial rollback, sometimes requiring teams to go all the way back to the drawing board for a fix.
Oh, wow.
This led to massive delays, ballooning costs, and a constant sense of playing catch-up. It was like akin to meticulously designing and building an entire house, only to discover a fundamental flaw in the foundation after the roof is on. The cost of fixing it at that point: astronomical.
Yeah, you can't just patch that easily.
Not at all. This rigid, sequential approach rapidly became out of sync with the accelerating pace of technological change and market demands. The business world was becoming agile, but software delivery remained rooted in this kind of industrial era mindset. That's precisely why we saw the emergence of agile practices. Agile methodologies introduced iterative and flexible development cycles, emphasizing frequent feedback loops, adaptive planning, continuous adaptation.
Right.
This dramatically improved how development teams worked, allowing them to deliver features faster and respond much more quickly to changing requirements. However, it's crucial to understand that Agile primarily focused on the development side. It still left this gaping chasm when it came to reliably getting that rapidly developed software into the hands of users and then maintaining it.
Yeah.
The operations part of the equation remained largely separate, basically a bottleneck awaiting its own transformation.
So Agile was a vital step, but it only solved half the equation. It makes perfect sense then that continuous integration and continuous delivery or deployment must have stepped in to truly begin bridging that lingering gap.
Precisely. The shift towards continuous integration, CI, and continuous delivery, CD, or continuous deployment, was a truly pivotal evolutionary step, a crucial precursor to DevOps. Continuous integration emphasizes that developers frequently merge their code changes into a central repository, often multiple times a day.
Yeah.
And each merge isn't just stored. It triggers automated builds and a comprehensive suite of automated tests. The profound benefit here is that issues, compilation errors, broken tests, integration conflicts, they're detected extremely early, often within minutes of introduction rather than weeks or months later during some large, painful release cycle.
Huge difference.
Huge difference. This ensures that the code base is almost always in a healthy, releasable state. Then, building directly on that foundation of CI, continuous delivery, and continuous deployment, automate the release process itself. Continuous delivery means that code, having passed all its automated tests and integrations, is always ready for release, and deployment can be triggered manually whenever the business decides. It means the friction of releasing is minimal.
Right.
Continuous deployment takes this a significant step further by automatically deploying every validated change directly to production, assuming all automated tests pass. No human gate required post-testing.
Wow, fully automated.
Fully automated. These practices inherently force development and operations teams to work more closely than ever before. They had to agree on standardized automated build processes, consistent testing environments, reliable deployment strategies. This collaborative imperative laid the crucial groundwork for what would soon crystallize into the DevOps movement.
It sounds like the silent, unsung hero woven through all these historical shifts, from Agile to CI/CD, was ultimately automation. It was like the Luke Fint making the machine run faster.
Without a doubt, automation became not just indispensable, but the very backbone of these evolving methodologies. Think about the sheer volume of tasks.
Yeah.
If you're frequently merging code, compiling, running hundreds or thousands of tests, and then deploying potentially multiple times a day, you absolutely cannot rely on manual processes.
No way.
Automation removed those soul-crushing manual bottlenecks, drastically reduced human error because machines are far more consistent than humans at repetitive tasks, and ensured consistency across different environments. It accelerated the entire software delivery pipeline, transforming weeks into minutes. And more profoundly, automation connected directly to breaking down silos. By forcing the creation of shared automated processes and pipelines, those manual handoffs, the inconsistent configurations, the associated blame games, they diminished. Everyone worked on the same automated pipeline, seeing the immediate, transparent results together, which fostered a shared sense of ownership and responsibility for the entire process, from code commit to production, not just their isolated piece of it.
It's truly fascinating to see how these deep-seated historical frustrations, these pain points that so many of us can relate to, organically led to such a powerful and transformative solution. You can probably reflect on analogous situations in your own work, completely outside of software, where historical silos or rigid manual processes might still be causing friction. Perhaps as a project moving from one department to another, encountering unexpected snags because of different tools, conflicting expectations, or just a simple lack of shared visibility that it works on my machine mentality isn't exclusive to code, is it?
Not at all. It's a very human tendency. The blueprint for collaboration, core principles of DevOps.
That historical context really sets the stage, doesn't it? Understanding why DevOps emerged is absolutely key to appreciating its genius. But now here's where it gets really interesting. We move from the why to the what. What does DevOps fundamentally stand for? This is the blueprint, the core principles that define how collaboration radically changes within an organization.
These principles are indeed the foundational pillars, and their successful adoption often dictates the ultimate success of any DevOps transformation. They aren't just abstract ideas, they are translated directly into concrete actions, observable behaviors, and a profound shift in mindset. While there are various ways to articulate them, we generally break them down into four deeply interconnected core principles: collaboration, automation, continuous improvement, and shared responsibilities. Let's dive deep into collaboration. This isn't merely about people talking more, it's about establishing specific, intentional communication tools and practices that become foundational for effective, integrated teamwork. We're talking about ubiquitous integrated project management tools where both developers and operations engineers can see the same tasks, the same priorities, the same progress, fostering shared situational awareness.
Right, everyone on the same page.
Exactly. We mean shared chat platforms that facilitate immediate cross-functional communication, allowing quick problem solving and knowledge exchange. And critically, cross-functional stand-ups where both teams are physically or virtually present, discussing daily progress, sharing blockers, collectively planning next steps. This active, ongoing, and transparent dialogue is engineered to systematically dissolve those insidious us versus them mentalities that created so much friction in the past. When teams actively collaborate, they build genuine empathy for each other's challenges, they understand the full life cycle and inherent trade-offs of the software they're building, and ultimately they start speaking the same language, working towards the same unified objective. It fosters a sense of psychological safety crucial for innovation.
So it's far beyond just a buzzword. It's about embedding tangible, deliberate communication strategies directly into the fabric of daily work. And then there's automation, which we've already identified as a key driver from its very origins. It sounds like it just becomes even more fundamental here.
Exactly. The importance of automation in DevOps simply cannot be overstated. It's not just about achieving speed, it's profoundly about enhancing reliability, ensuring repeatability, and significantly reducing the cognitive load on engineers. When you automate repetitive, manual tasks, whether it's building code, running comprehensive test suites, provisioning complex infrastructure environments, or deploying applications to production, you virtually eliminate the vast majority of human errors. This frees up highly skilled engineers from tedious, error-prone grunt work, allowing them to focus their intellect and creativity on more complex, value-adding activities like architectural design, problem-solving, continuous optimization. In a DevOps context, automation is the beating heart of continuous processes. Automated testing ensures quality is baked in from the earliest stages. Automated infrastructure provisioning guarantees environments are consistent and reproducible every time. And automated deployments ensure rapid, reliable, consistent releases regardless of how often they occur. It's the engine that powers the unparalleled efficiency and consistency of a true DevOps pipeline.
And the true beauty of that pervasive automation is how seamlessly it facilitates the next principle. Continuous improvement. You can't really improve what you can't measure or iterate on quickly, right?
You've hit on a critical connection. Continuous improvement is inherently an iterative cycle, relentlessly fueled by data and feedback. It's about cultivating a mindset of constant learning, adaptation, and optimization. This means that after every deployment, after every incident, or even after a routine operational period, teams don't simply move on to the next task. They actively and systematically seek to understand what went well, what could be improved, and what fundamental lessons can be learned to enhance future performance.
Learning loops.
Exactly, learning loops. This is precisely where measuring success through robust metrics and structured feedback loops becomes absolutely crucial. Practices like blameless postmortems, where the focus is rigorously on identifying process failures and systemic weaknesses rather than individual blame, and regular team retrospectives are vital.
That blameless part sounds key.
Oh, it's huge. It changes the whole dynamic. Teams meticulously analyze their deployment frequency, their lead time for changes, and critically, how quickly they recover from issues, mean time to recovery. They use these hard metrics to identify specific areas for improvement and then iterate on their processes and tooling. It's a perpetual, never-ending quest for operational excellence, where every challenge is seen as an opportunity to learn and get better.
That makes perfect sense. It's that constant refinement. And then, tying it all together, the idea of shared responsibilities. It sounds like the logical, perhaps even inevitable, conclusion of all these principles working in concert.
It truly is the capstone, and arguably the most impactful cultural shift. This principle fundamentally redefines ownership, shifting it from isolated individual departments to a collective, cross-functional team. What this means in practice is that developers gain a much deeper awareness of operational concerns. They start thinking about how their code will run in production, how it will be monitored, what its resource footprint will be, how it will be supported.
So they're thinking beyond just the code itself.
Exactly. And simultaneously, operations teams gain a much richer understanding of development goals, the business value of new features, and the inherent trade-offs involved in software delivery. This profound shift fosters a stronger, far more empathetic team culture where everyone feels genuinely invested in the entire software lifecycle, from initial ideation and coding to deployment, monitoring, and ongoing maintenance. It dismantles the "it's not my problem" mentality, replacing it with a collective "we're all in this together and we succeed or fail as one." It fosters a powerful sense of collective ownership.
Can you give us some more detailed, abstract, real-world examples of how organizations have successfully adopted these principles? Because it sounds incredibly compelling in theory, but how does this symphony of collaboration and automation truly play out on the ground?
Certainly. Let's imagine a large e-commerce organization that was, say, struggling with painfully slow feature releases maybe once every few months, leading to lost market opportunities and frustrated customers.
Okay, pretty common scenario.
Very common. By truly embracing these principles, their transformation might look something like this. They start by breaking down traditional departmental boundaries and implementing ubiquitous shared chat platforms and integrated project boards, fostering a culture of radical transparency and immediate collaboration. No more throwing it over the wall. Instead, developers and operations engineers are now in the same chat channels, attending the same daily stand-ups, and co-owning tasks.
Real integration.
Real integration. Next, they invest heavily in automation for their entire build, test, and deployment processes. This means instead of manual approvals and checks, code changes are automatically picked up by a CI/CD pipeline, tested against maybe hundreds of thousands of scenarios, and then automatically deployed to a staging environment, sometimes even directly to production if all checks pass. This dramatically reduces manual errors and slashes release times from months to days, maybe even hours. Through frequent, blameless retrospectives after every significant release or incident, they openly identify bottlenecks, discuss what went wrong and right, and implement concrete changes to their processes, showcasing continuous improvement. They might realize a specific test suite is flaky or a certain deployment step is manual, and they quickly automate or refine it. Finally, by having developers not only write code, but also participate in its operational support, perhaps being on call for their own services, and operations engineers being involved in early design discussions about system architecture, they cultivate a deep sense of shared responsibility.
Everyone owns it.
Everyone owns it. Everyone is now directly invested in the stability and performance of the production system, the result. This organization is now deploying new features multiple times a week. Their software is significantly more stable. Customer satisfaction metrics are soaring due to rapid innovation and fewer bugs. And their teams report dramatically higher job satisfaction because they feel empowered, united, and truly impactful. The collaboration and automation don't just speed things up, they fundamentally rewire the entire organizational DNA.
That's a powerful story of transformation, even in the abstract. It truly underlines that these principles aren't exclusive to software teams. Think about it. You can easily apply these same principles: radical collaboration, intelligent automation of repetitive tasks, relentless continuous improvement fueled by feedback, and a culture of shared responsibilities to almost any team or project you might be involved in, regardless of the industry. Imagine how much smoother any multi-departmental project could run with this kind of truly unified, empathetic approach. It really begs the question, Where in your world could breaking down those internal silos unlock a breakthrough? 3. The human element. Cultivating a DevOps culture. So we've covered the why and the what of DevOps, its historical imperative and its core principles. But here's the crucial pivot. DevOps isn't just about tools and processes. That's perhaps the biggest misconception. It's profoundly, fundamentally about people, and most crucially about culture. It's the human element, the invisible operating system of an organization that truly drives its success or dooms it to failure.
You've truly hit on the most critical aspect, the one that often differentiates success from stagnation. You could buy and implement every cutting-edge tool and meticulously define every process. But if the underlying culture isn't aligned with DevOps principles, the initiative will inevitably falter. That's why fostering a deep-seated culture of trust and collaboration is paramount. When team members genuinely trust each other, when they believe in each other's competence and positive intent, they are far more willing to share information openly, to experiment without fear of reprisal, to admit mistakes transparently, and to take calculated risks that drive innovation.
That psychological safety piece.
Exactly. This profound sense of trust and psychological safety directly translates into higher productivity and significantly higher job satisfaction because individuals feel safe, supported, and valued. It reduces the insidious fear of failure, which in turn actively encourages the kind of experimentation and learning essential for rapid delivery and continuous improvement. Without trust, communication becomes guarded and collaboration becomes superficial.
So it's not just a nice to have, it's foundational. But how do organizations actually cultivate this kind of transformative culture? It sounds like it needs to be incredibly intentional, not just hoped for.
It absolutely must be intentional and relentlessly pursued. There are several actionable strategies that organizations successfully employ. One key strategy, which is often counterintuitive for traditional organizations, is the adoption of blameless postmortems. When an incident occurs, and incidents will occur, the focus rigorously shifts from who made the mistake to what went wrong in the process that allowed this mistake to happen, and how can we prevent it from recurring.
Focusing on the system, not the person.
Precisely. This fosters radical transparency, encourages learning from failure, and builds a sense of collective responsibility rather than individual culpability and finger-pointing. The surprising insight here is that blamelessness actually leads to more accountability because everyone is invested in fixing the systemic issue, not just covering their tracks.
Interesting paradox.
It is. Another crucial strategy is promoting cross-functional training. This means developers might spend dedicated time shadowing operations engineers, understanding the complexities of production environments and real-world system behavior. Conversely, operations professionals might learn some basic coding or scripting, gaining insight into the development process. This mutual exposure builds empathy and a shared mental model of the entire software delivery lifecycle. Promoting transparency in goals, progress, metrics, even failures helps build a deeper shared understanding and cements trust across teams. And let's not overlook the softer side. Regular team-building activities, even informal ones, can play a significant role in fostering camaraderie and strengthening interpersonal bonds, which are the bedrock of true collaboration.
And none of this cultural transformation, especially at scale, happens without genuine leadership buy-in and active participation, right? They can't just mandate it from on high. They have to be actively involved, leading by example.
Precisely. The role of leadership in initiating, sustaining, and scaling this change is absolutely vital. Leaders are not merely supportive figures, they must be active, vocal champions of the DevOps vision. This means articulating a clear, compelling why, explaining why DevOps is not just a technological choice, but an existential imperative for the organization's future, its growth, its competitiveness.
Connecting it to the bigger picture.
Yes, they must visibly provide the necessary resources, whether it's budget for new tools, dedicated time for extensive training and experimentation, or the allocation of key personnel to lead the charge. And most importantly, leaders must consistently model the desired behaviors. If leaders expect radical collaboration and blamelessness, they must demonstrate it in their own interactions and their response to incidents.
Want to talk.
Exactly. If they want teams to experiment, they must create an environment where failure is seen as a learning opportunity, not a career-ending event. Leadership must actively work to dismantle entrenched organizational barriers like rigid hierarchical structures, conflicting departmental incentives, or archaic approval processes, and empower teams to make faster, more informed decisions, fostering true autonomy within a guided framework. Without this top-down commitment, this consistent messaging and active involvement, cultural transformation is incredibly difficult, often devolving into a fragmented, temporary initiative.
It sounds like even with leadership fully on board and all the best intentions, there's always going to be some natural resistance to change among teams. It's just a human element, right? How do you address that without resorting to mandates?
That's an insightful point, and it's something every organization will encounter. Resistance is a natural human reaction to change, and it's critical to acknowledge that rather than dismiss it. Common reasons for resistance include a fundamental fear of the unknown. How will my job change? Will I be able to learn these new skills? There's also concern about a perceived loss of control over one's established domain, or simply the comfort and efficiency that comes from deeply ingrained existing routines, even if those routines are inefficient overall. People often perceive an increased workload during the transition period as well.
Sure, change is hard.
It is. To effectively overcome this resistance, clear, proactive, and empathetic communication of the benefits is paramount. It's not just about what DevOps does for the company, it's about explaining how it will make their jobs easier, more efficient, more satisfying, and ultimately more secure in a competitive landscape. Frame it in terms of reduced toil, more interesting work, greater impact. Crucially, involving team members directly in the transition process itself can significantly reduce resistance.
Give them ownership.
Exactly. When people feel heard, when their concerns are addressed, and when they have a genuine hand in shaping the change, they are far more likely to embrace it and champion it. Providing adequate, ongoing training and robust support for new skills is non-negotiable. Don't just tell them to use new tools or adopt new processes. Actively teach them how, provide hands-on workshops, give them dedicated space and time to practice and make mistakes in a safe environment. Celebrating quick wins, small early successes that demonstrate tangible benefits can also build vital momentum and show skeptical team members that the new way of working actually yields positive immediate results. It's fundamentally a process of continuous education, deep empathy, and genuine empowerment.
This section is so highly relatable, isn't it? For anyone who's ever experienced or led significant organizational change, this truly highlights how the environment you create, the culture you meticulously cultivate, dictates whether an organization promotes innovation and agility or whether it simply stagnates, clinging to outdated, comfortable inefficiencies. It's the difference between a team that embraces a dynamic future and one that's perpetually stuck in old ways, silently eroding its own potential. 4. The workbench. Essential DevOps tools. Okay, we've thoroughly covered the history and foundational principles of DevOps, and we've truly delved into how crucial culture is to its success. Now let's shift our focus to the more tangible, practical components, the tools of the trade that form the technological backbone and enable these transformative DevOps practices. Think of it as peeking into the highly optimized workbench of a modern software delivery team. Okay, let's unpack this. The actual ecosystem of tools.
This is truly where the rubber meets the road, so to speak. The technological backbone of DevOps isn't a single magical tool, but rather an interconnected, highly integrated set of tools that strategically support every stage of the software delivery pipeline. These tools are meticulously designed to enhance development efficiency, accelerate speed, bolster reliability across continuous integration, continuous delivery, collaboration, automation, you name it. They effectively automate tasks that were once manual, error-prone, and time-consuming, allowing teams to move faster and with far greater confidence and consistency.
Can you walk us through some of the absolute key players in this sprawling tool landscape? I often hear names like Jenkins, Docker, and Kubernetes. What specific roles do they play, and how do they fit together to create a powerful synergy?
Certainly. Let's break down some of the giants in this space. We'll start with Jenkins. Jenkins is a leading open-source automation server, an absolute powerhouse primarily used for orchestrating continuous integration and continuous delivery pipelines. Think of it as the conductor of your software orchestra.
Okay, I like that analogy.
It allows you to automate virtually the entire software development lifecycle, from the moment a developer commits code, compiling it, running exhaustive suites of automated tests, generating build artifacts, and then deploying applications to various environments. Its immense popularity stems not only from its robust capabilities, but also from its extensive plugin ecosystem, which makes it incredibly extensible and adaptable to almost any programming language, project type, or technology stack. Essentially, Jenkins defines and orchestrates the automated steps in your CI/CD pipeline, ensuring everything runs in sequence and on schedule.
So, the workflow engine.
Precisely. Then there's Docker. Docker is a revolutionary containerization platform. The most common analogy, and a highly effective one, is to think of it like a standardized shipping container for software.
Right, the shipping container analogy.
Exactly. Just as a physical shipping container can carry any cargo furniture, electronics, food, and be transported reliably on any ship, train, or truck, a Docker container packages an application along with all its dependencies, every library, framework, configuration file, operating system setting into a single, isolated, lightweight unit. The profound benefit here is consistency. This container ensures that the application runs identically across different environments, whether it's a developer's laptop, a testing server, a staging environment, or the production cloud.
Oh, the works on my machine killer.
Exactly. This consistency is a game changer, fundamentally solving the classic "it works on my machine" problem and dramatically simplifying deployment and reducing environment-related issues. It enables true immutability, meaning what you test is exactly what you deploy.
Got it. Consistent packages.
Consistent packages. And building directly on the foundation laid by Docker, we have Kubernetes. Kubernetes is an open source system that has become the de facto standard for automating the deployment, scaling, and management of containerized applications at scale. While Docker creates the individual standardized shipping containers for your software, Kubernetes acts as the incredibly intelligent orchestration engine that manages large clusters of these containers.
So, managing all the Docker containers.
Precisely. It ensures they run efficiently, reliably, and are self-healing. Kubernetes handles complex tasks like load balancing incoming traffic across multiple instances of your application, automatically restarting failed containers, rolling out new versions of your software with zero downtime, and managing resource allocation to optimize performance and cost. It's particularly popular and powerful for managing complex microservices architectures, allowing organizations to manage hundreds or even thousands of interconnected services with remarkable agility and resilience.
So, if I'm understanding this correctly, Jenkins orchestrates the automated flow of work, Docker packages the applications consistently into portable units, and Kubernetes then intelligently manages and scales those packaged applications in production. They all seem to solve very specific yet deeply interconnected problems. This feels like a paradigm shift beyond just individual tools.
That's a perfect encapsulation of their symbiotic relationship. These tools and others like them are popular precisely because they directly address common, significant pain points in the traditional software delivery process, leading to dramatic improvements in speed, reliability, and consistency. However, it's absolutely crucial to understand the importance of choosing the right tools for your specific team and context. There is no one-size-fits-all magic solution.
Right, context matters.
Hugely. Factors such as your team size and its existing skill sets, your current infrastructure, cloud native versus on-premise legacy systems, the specific needs and complexity of your project, your budget, open source versus commercial solutions, and even your regulatory requirements all profoundly influence the best tool choices. A small, nimble startup might begin with simpler, fully managed, cloud-native services, while a large regulated enterprise might opt for more robust, self-hosted, and deeply configurable solutions.
And I can only imagine that once you've meticulously picked your tools, the process of integrating them seamlessly into a cohesive tool chain can present its own set of significant challenges. It's not just about picking the right Lego bricks, it's about making sure they actually snap together properly.
You're absolutely right to highlight that. Individual tools, while powerful in isolation, achieve their true transformative strength only when they are seamlessly integrated into a cohesive tool chain. This means ensuring that data flows smoothly and automatically between them, and that actions in one tool can reliably trigger actions in another, creating a fully automated end-to-end pipeline. However, this integration is rarely straightforward.
Yeah, I bet.
Common challenges include fundamental compatibility issues between different vendor products or various open source projects. They weren't always designed to work together perfectly. Then there's the complexity of managing the vast data flow and maintaining consistency across the entire pipeline, from code repositories to deployment logs. The inherent complexity of setting up and initially configuring these integrations, often requiring specialized scripting and deep knowledge of each tool's APIs, can be immense.
Sounds like a job in itself.
It often is. And finally, there's the ongoing maintenance overhead. Keeping these integrated tool chains updated, secure, and functional as each individual component evolves is a continuous, non-trivial effort. Teams can sometimes spend 30% or more of their time just maintaining their CI/CD scripts and integrations, which itself becomes a bottleneck if not managed carefully. It demands a significant investment in expertise and continuous attention to ensure that your tool chain remains a well-oiled machine, not a series of duct tape solutions.
That truly adds a layer of depth. Even if you're not directly working with these specific tools yourself, understanding their core function and how they interact provides such valuable insight into the complex, often invisible infrastructure behind the modern digital services we all rely on every day. It's like peeking behind the curtain of your favorite apps and websites to truly grasp how they're built, updated, and delivered so seamlessly, often multiple times a day. It really makes you appreciate the orchestration involved.
Definitely. It's a complex dance. V-gauging progress, measuring DevOps success.
So, an organization has embraced DevOps. They've implemented the principles, started the cultural shift, and picked their sophisticated tool chain. Now comes the truly crucial question. How can they measure the effectiveness of their DevOps transformations? It's simply not enough to just implement. You absolutely need to know if it's actually working, if it's delivering on its promise. What are the key performance indicators? What should we be looking at?
This is where the rubber meets the road for demonstrating tangible value. While the cultural shift is inherently qualitative, its impact absolutely needs to be measured quantitatively to validate the transformation and guide continuous improvement. The overarching goal of DevOps is faster, more reliable, more stable software delivery, and these specific metrics directly reflect those goals, providing a clear scorecard of performance.
Okay, so hard numbers.
Hard numbers. One of the most important quantitative metrics, often considered a cornerstone, is deployment frequency. This measures how often new code is successfully deployed to a production environment. Think about what this signifies. If an organization can deploy new features or bug fixes multiple times a day or even multiple times a week rather than once a month or once a quarter, it unequivocally signifies high speed, agility, and a very smooth, reliable delivery pipeline.
Right. More releases means faster value.
Exactly. It means they can deliver value to customers much faster, respond to market changes with lightning speed, and iterate based on immediate feedback more frequently. The counterintuitive insight here is that more frequent deployments, when done correctly, actually lead to less risk, because each change is smaller and easier to debug if an issue arises.
So counterintuitively, the more often you deploy, the better, generally speaking, because it means your process is so robust that frequent small changes are safer than infrequent large ones, like tiny steps versus giant leaps.
Precisely. It indicates a highly automated, well-tested, and reliable pipeline, where small incremental changes are the norm. Another absolutely critical metric is lead time for changes. This measures the total time it takes for any change, from a new feature to a bug fix, to go from a developer committing the initial code to that code being successfully deployed and running live in production.
The whole life cycle time.
A whole life cycle time. This metric encompasses the entire value stream. Coding time, testing time, code review time, the actual deployment process. A significantly shorter lead time indicates a highly efficient, streamlined, low-friction delivery process. It's a comprehensive end-to-end measure of your overall development and operations efficiency, showcasing how quickly an idea can go from concept to user value.
Got it. Speed from idea to reality.
Exactly. And then there's mean time to recovery, MTTR. This measures the average time it takes to restore service after a disruption, like a bug, a system failure, an unexpected outage. A low MTTR signifies not just strong system resilience, but also highly effective incident response capabilities. It means that when things inevitably go wrong, because in complex systems they always do, at some point your team can quickly identify, diagnose, address, and resolve the issue, minimizing the impact on users and the business.
How fast can you fix things when they break?
Basically, yes. These three metrics, deployment frequency, lead time for changes, and mean time to recovery, are often collectively referred to as the DORA metrics from the DevOps Research and Assessment Group, and are widely recognized as the most powerful and correlated indicators of true DevOps performance and organizational health.
Those quantitative metrics certainly paint a clear, data-driven picture of performance and efficiency. But you mentioned earlier the importance of qualitative metrics. How do those fit into the picture, and what kind of insights do they provide that numbers alone can't capture?
That's a crucial distinction. Quantitative metrics tell you what is happening, are we deploying faster, but they don't always reveal the why, or critically, how it's impacting the people involved in the customers. That's where qualitative metrics become indispensable. It's incredibly important to measure things like team satisfaction through regular anonymous surveys, structured feedback sessions, and by closely observing engagement levels and employee retention rates.
So are people actually happier?
Exactly. Are your developers and operations engineers happier in their roles? Do they feel less stressed by fire drills and blame games? Is the internal blame culture visibly diminishing? Higher job satisfaction directly correlates with increased productivity, lower burnout, and significantly reduced employee turnover, which is a huge cost saving in itself. A truly successful DevOps transformation makes work better for the people doing it.
Makes sense. Happy teams build better things.
Absolutely. Similarly, customer feedback is paramount. This can be gathered through various channels: user reviews, detailed support tickets, direct customer surveys, social media sentiment analysis, or even usability testing. Are your users experiencing fewer bugs or system outages? Are new features being delivered that genuinely meet their needs and desires? Are their issues resolved faster and more effectively? These qualitative insights provide essential context, validate the actual impact of your DevOps transformation on both your internal teams and your external users, and ensure that the speed of delivery is actually translating into a superior user experience and real business value. They help you avoid the trap of optimizing for vanity metrics and focus on what truly matters.
And to effectively collect, analyze, and make sense of all this rich data, both quantitative and qualitative, I imagine organizations need a robust set of tools for monitoring and reporting these KPIs. Otherwise, you're effectively flying blind, aren't you?
You're absolutely right. To harness the power of these metrics, organizations need robust systems that can seamlessly collect, analyze, and visualize this vast amount of data. This includes sophisticated monitoring tools that capture system performance data in real time, comprehensive logging systems that record every event and interaction, and powerful reporting tools that can aggregate, filter, and display KPIs in clear, actionable dashboards. Think of tools like Prometheus for monitoring, Splunk, or maybe the ELK stack for logging, and Grafana for visualization. Without these integrated tools, you're essentially operating on guesswork and anecdotal evidence.
Right. Data needs visibility.
Exactly. They allow teams to identify trends, pinpoint bottlenecks, proactively detect anomalies, and crucially, make truly data-driven decisions about where to focus their precious time and resources for continuous improvement efforts, ensuring that every iteration moves them closer to their goals.
It's so powerful to see how these principles of applying rigorous metrics and robust feedback loops can be leveraged not just in the world of software, but in your own pursuits, whether personal or professional. It's a universal principle for ensuring continuous improvement and making truly meaningful progress in any endeavor where you want to go beyond guesswork and genuinely track your evolution and impact. What gets measured gets improved, right?
That's the core idea, yes. 6. Navigating the roadblocks. Overcoming common DevOps challenges.
Now, while DevOps offers truly immense game-changing benefits, its implementation, as with any major transformation, is rarely a straight line. Every superhero story has its challenges, its formidable villains, and DevOps is certainly no different. It's crucial to acknowledge these common roadblocks so we can figure out how to anticipate, plan for, and ultimately navigate them effectively.
That's a critical, often overlooked point. Many organizations, even those with strong leadership buy-in, encounter predictable obstacles during their DevOps journey. One of the most significant and pervasive challenges is integrating legacy systems into modern DevOps practices. These are the older, established infrastructures and applications that might be absolutely critical to the business's core operations, perhaps powering revenue or managing essential data, but they were almost certainly built in a pre-DevOps era.
The old stuff that still runs the business.
Exactly. They often have monolithic architectures, rely heavily on manual deployment processes, or utilize proprietary technologies that don't easily integrate with automated pipelines, modern cloud-native tools, or containerization strategies. It's like trying to put a square peg in a round hole, or worse, fitting an antique steam engine into a modern electric car assembly line.
Yeah, tricky.
Very tricky. Strategies to integrate or manage these legacy systems are varied and require careful planning. One approach is gradual modernization, where you incrementally update components or re-platform services one piece at a time, rather than attempting a risky, complete rewrite. Another common strategy is wrapping legacy systems with APIs, application programming interfaces, essentially creating a modern, standardized interface that allows newer systems to interact with them in a controlled, automated way without directly touching the complex legacy code.
Building a bridge to the old system.
Precisely. The strangler pattern is also popular. This involves building new functionalities around the legacy system, gradually strangling or replacing its old components with modern, DevOps-friendly microservices until the original legacy system is eventually retired. Sometimes organizations opt to run modern and legacy systems in parallel during a lengthy transition period, allowing for a phased and less disruptive migration. It's a complex undertaking that requires significant architectural insight and meticulous long-term planning and a deep understanding of dependencies.
And we touched on this earlier in the context of culture, but resistance to change remains a persistent human element when it comes to the actual implementation phase, doesn't it? It can resurface even after initial enthusiasm fades.
It absolutely does, and it's often, ironically, the biggest non-technical hurdle. Resistance isn't necessarily malicious, it's a natural human reaction. During implementation, it often arises from a deeper, more personal fear of the unknown. Will my skills become obsolete? Will I be able to keep up? There's also concern about a perceived loss of control over one's domain, especially for operations teams who traditionally controlled deployments, or simply an increased workload during the transition period as people learn new tools and processes while still maintaining the old ones. Teams might simply be comfortable with their existing familiar routines, even if they're inefficient.
The comfort zone issue.
Exactly. The strategies to overcome this require relentless effort. Proactive, transparent, and continuous communication about why the change is happening, what the tangible benefits are for them individually, and a clear vision of the brighter future. Demonstrating quick wins early on, small, tangible successes like automating a particularly painful manual task can build vital momentum and show skeptical team members that the new processes actually work and visibly improve their daily lives.
Show. Don't just tell.
Precisely. Dedicated, hands-on training programs and ongoing support are non-negotiable to equip teams with the new skills and confidence they need to adapt. It's an investment in your people. The crucial insight is that you have to meet people where they are, acknowledge their fears, and guide them through the process with empathy and support.
That directly brings us to another challenge, skill gaps. If you're introducing a whole new way of working, often with sophisticated tools, your existing teams will inevitably need a whole new set of expertise.
Indeed. DevOps fundamentally requires a new blend of skills and, just as importantly, a deeply ingrained cross-functional mindset. Many traditional developers might have limited experience with cloud infrastructure, networking, security with best practices, or monitoring tools. Conversely, many operations teams, historically focused on manual server management, might lack modern scripting, coding, or agile development skills. This disparity creates significant skill gaps that can bottleneck adoption.
The T-shaped skills idea.
Very much so. The strategies here are centered around robust training and upskilling teams for new processes and technologies. This could manifest as intensive internal workshops, sponsorship for external certifications, online learning platforms, or even dedicated DevOps boot camps. Fostering a continuous learning culture is absolutely essential, where knowledge sharing, internal mentorship programs, and communities of practice are actively encouraged and rewarded. Investing in your people's growth isn't just a benefit, it's key to building the internal capabilities required for a successful and sustainable DevOps transformation. It's often more effective to reskill existing trusted employees than to constantly hire from outside.
And for all of these individual strategies to coalesce and truly work, you need genuine buy-in from the entire organization, from the top floor to the shop floor. It sounds like you need not just a plan, but a truly strong, compelling vision that resonates with everyone.
You've hit on the fundamental glue that holds it all together. Building a truly compelling vision to win buy-in is paramount. It's simply not enough for leadership to declare, we're doing DevOps because everyone else is, or it will save us money.
Yeah, that won't cut it.
Not at all. Leaders must clearly articulate the profound why this specific change is existentially necessary for the organization's long-term survival, its ability to innovate, its growth, its competitive edge in the market. They need to paint an inspiring picture of the ultimate benefits, not just for the company's bottom line, but for the individuals involved. Less toil, more interesting and impactful work, greater autonomy, increased opportunities for learning, and a greater sense of shared purpose and job satisfaction. A clear, inspiring vision fosters motivation, commitment, and ownership across all levels of the organization, transforming passive recipients of change into eager, invested participants. It turns a mandate into a shared mission.
It's truly fascinating how these challenges and their solutions mirror those you might face in almost any complex endeavor, whether personal or professional. How do you identify and strategically address legacy systems, be it old habits, outdated tools, or even rigid mental models or resistance to change in your own life or projects. The solutions often involve remarkably similar principles: gradual, strategic transformation, empathetic and clear communication, continuous skill development, and most importantly, an inspiring vision to rally around. It really puts the human element at the heart of any successful transformation.
It absolutely does. It's always about the people. 7, the horizon, DevOps, and the future of software development.
We've covered the past, the present, and the inherent challenges of DevOps. Now let's gaze into the crystal ball a bit, peering into the near future. So what does this all mean for tomorrow? The future of software development, driven by DevOps, looks incredibly fascinating.
The future of DevOps is indeed an incredibly exciting and rapidly evolving landscape. One of the most significant ongoing trends is the ever-blurring, evolving relationship between development and operations. We're seeing concepts emerge that push the boundaries even further, embedding operational concerns directly into the engineering mindset.
Going beyond just bridging the gap.
Exactly. A prime example of this evolution is site reliability engineering, SRE. While SRE is often described as what happens when you ask a software engineer to design an operations function, it's more than just a job title. It's a discipline where operational tasks are treated as fundamental software engineering problems. This means SRE teams, often composed of highly skilled software engineers, focus on creating automated solutions to manage infrastructure, improve system reliability, proactively identify and mitigate risks, and drastically reduce manual toil.
Applying engineering rigor to ops.
Precisely. They embed reliability principles directly into the development process, aiming for ultra-stable, highly available systems by applying rigorous engineering principles, data analysis, and automation to traditional operational challenges. It's essentially DevOps with an incredibly strong reliability, engineering, and data-driven focus. Another fascinating and increasingly prominent concept is GitOps. This methodology leverages Git, the ubiquitous version control system, as the single authoritative source of truth for both declarative infrastructure and applications.
Everything in Git.
Everything in Git. Instead of manual configurations, SSH commands, or imperative scripts, all changes to your infrastructure, like creating a new server or configuring a database, and your applications are made by committing code to a Git repository. An automated process then continuously monitors this Git repository and ensures that the actual state of your deployed system always matches the desired state declared in Git.
Wow, declarative and auditable.
Exactly. This brings all the profound benefits of version control auditability, easy rollbacks to any previous state, transparent collaboration, a clear history of every change to infrastructure management, making operations far more transparent, reliable, and auditable. It's infrastructure as code taken to its logical, automated conclusion.
That sounds like a truly unified approach where literally everything is treated as code, even the infrastructure, ensuring traceability. And with all this talk of advanced automation, it feels like artificial intelligence and machine learning must inevitably play an increasing role, right? It feels like the next frontier for optimization.
Absolutely. The increasing and transformative role of AI and machine learning in DevOps workflows is one of the most exciting trends on the horizon. AI and ML can profoundly enhance DevOps processes in multiple ways, moving beyond just simple automation to true intelligence and predictive capabilities. Imagine the power of predictive analytics for system failures, where AI algorithms can analyze vast quantities of logs, metrics, historical data to anticipate potential outages before they occur, allowing teams to proactively address issues and prevent downtime.
Predicting problems before they happen.
Exactly. Moving from reactive firefighting to proactive prevention. We're also seeing intelligent automated testing, where AI can dynamically generate more effective test cases, identify critical test paths based on code changes, or even learn from past failures to intelligently prioritize testing efforts, drastically reducing test execution time while increasing coverage. Anomaly detection and monitoring is another key application. AI can spot subtle, unusual patterns in system behavior that human eyes or traditional threshold-based alerts might completely miss, signaling potential problems before they escalate into full-blown incidents.
Smarter alerting.
Much smarter. Automated incident response, where AI can not only diagnose issues rapidly but also trigger self-healing actions or recommend precise remediation steps, could drastically reduce mean time to recovery. And finally, smart resource allocation. using AI to dynamically optimize cloud spending and infrastructure usage based on real-time demand, predicting future needs, and automatically scaling resources up or down for peak efficiency and cost savings. The goal is to make the entire software delivery pipeline significantly more intelligent, more self-optimizing, and far more resilient.
It sounds like a truly thrilling vision of the future. What are your broad predictions for the next 5 years in DevOps implementation based on these emerging trends and the foundational principles we've discussed today?
Looking ahead over the next 5 years, I predict several key developments. Firstly, we will see even wider, more pervasive adoption of DevOps practices, not just within the tech industry, but across a much broader spectrum of traditional enterprises, finance, healthcare, manufacturing, government, as they increasingly recognize the existential competitive advantage it offers.
Going mainstream.
Totally mainstream. Secondly, there will be deeper and far more sophisticated integration of AI and ML throughout the entire DevOps lifecycle, moving beyond just monitoring to proactive problem solving, intelligent automation, and genuine self-correction within systems. Automation itself will become even more ubiquitous and intelligent, with less and less direct human intervention required for routine or even semi-complex tasks, shifting human effort to higher value activities. Finally, and crucially, there will be an even stronger and more integrated emphasis on security being woven directly into the DevOps pipeline from the very beginning, this concept known as DevSecOps. Security will no longer be a bolted-on afterthought or a separate gate, but an intrinsic, automated, continuous part of the entire software delivery and operational process.
Security built in, not bolted on.
Exactly. This holistic integration of security will be non-negotiable.
That's a powerful and thought-provoking vision of the future. It makes you think. Given this accelerating evolution in technology and collaboration, what new skills, what new perspectives, and what new mental models might be absolutely essential for you to navigate and thrive in this evolving landscape? It's clear that adaptability, a perpetual learning mindset, and a comfort with constant change will be more critical than ever.
Absolutely. Continuous learning is key. 8. Expanding horizons. Scaling DevOps in your organization.
So we've explored the ins and outs of implementing DevOps on a smaller scale, diving into the principles and tools. But what happens when an organization grows exponentially? How do you make these principles and practices work effectively for a whole city of developers, potentially spread across different departments and geographies, or even an entire global enterprise? Scaling DevOps is its own unique, often complex challenge, isn't it?
Scaling DevOps effectively is indeed a substantial undertaking, as it moves beyond optimizing individual teams to coordinating and aligning multiple, often diverse groups. One of the primary challenges is aligning multiple teams under a unified DevOps culture and set of practices. Different teams might have their own deeply established ways of working, their preferred tools, their own historical biases, even their own distinct subcultures. To scale successfully, you need to establish common platforms, shared goals that transcend departmental lines, consistent cultural messaging, and clear communication channels across all teams, without stifling their autonomy. It's like orchestrating a massive symphony rather than a small ensemble.
Finding that balance between consistency and freedom.
Exactly that balance. Strategies to achieve this often include creating internal communities of practice forums where engineers from different teams can regularly share knowledge, best practices, lessons learned, establishing shared services for common capabilities like CI/CD pipelines, centralized monitoring, unified logging, and artifact repositories can provide a consistent and standardized foundation that all teams can leverage. This provides consistency and economies of scale while empowering individual teams to innovate within that framework. The goal is to strike a delicate balance between providing a robust, consistent organizational framework and allowing individual team autonomy and innovation. It requires strong, empathetic communication and leadership that fosters a "we're all building this together" mentality.
And as organizations grow, especially in highly regulated industries like finance or healthcare, governance and compliance must become an even bigger, more integrated part of the picture, right? It's no longer just about speed, it's about speed with control.
Absolutely. The importance of governance and compliance in larger implementations cannot be overstated. As organizations expand and mature, regulatory requirements, whether for data privacy like GDPR, financial transactions like SOX or PCI DSS, or industry-specific standards become much more critical and complex. Internal governance, like stringent change management policies, detailed audit trails, strict access controls, also becomes paramount to manage risk and ensure accountability.
Lots more rules to follow.
Lots more rules. The profound challenge is how to seamlessly integrate these critical security protocols, auditing requirements, requirements and compliance standards directly into the fast-paced automated DevOps pipeline without sacrificing the very agility and speed that DevOps promises. This often means shifting security left, embedding security checks, vulnerability scanning, compliance gates much earlier in the development lifecycle, even at the code commit stage.
Building security in from the start.
Exactly. It involves automating security testing, ensuring all changes are rigorously traceable and auditable, and implementing automated guardrails that prevent non-compliant deployments. It's about building compliance into the automated pipeline as a first-class citizen, not layering it on as a manual, bureaucratic afterthought that slows everything down. It means security and compliance become enablers of speed, not impediments.
It's always incredibly helpful to hear about real-world scenarios, even abstract ones, to ground these concepts. Can you give us some high-level examples of successes and failures from case studies of scaling DevOps in large organizations? What works, what doesn't?
Certainly. In terms of successes, we've seen very large organizations successfully scale DevOps through models often called federated DevOps or DevOps centers of excellence. In a federated model, a central DevOps team or platform team provides common tools, standardized platforms, best practices, but individual product teams or business units retain significant autonomy to adapt and innovate within that framework. This provides necessary consistency while fostering distributed innovation.
Central guidance, local execution.
Kind of like that, yeah. Another successful strategy is establishing dedicated centers of excellence for DevOps, which act as knowledge hubs, provide expert guidance, offer internal consulting, and drive adoption of best practices across the entire organization. These approaches help disseminate knowledge, cultivate a shared culture, and empower teams without imposing rigid, suffocating top-down mandates. They foster organic growth.
Okay, so enabling rather than dictating.
Exactly. On the flip side, failures in scaling DevOps often occur when organizations try to impose it as a rigid, top-down mandate without understanding the profound cultural implications or investing in the human element. If leadership tries to force new tools and processes without addressing the underlying cultural resistance, without providing adequate sustained training, or without fostering genuine bottom-up buy-in, the initiative often crumbles or becomes mere DevOps theater, a superficial adoption without real change.
Just going through the motions.
Right. Another common failure point is neglecting to address cultural resistance at scale across different business units or geographical regions. If individual teams or long-established departments are left out of the cultural transformation, they become intractable bottlenecks, preventing broader organizational adoption and creating islands of inefficiency. Success in scaling DevOps hinges on finding that delicate balance between standardization and autonomy, and critically, relentlessly managing the human element and cultural integration across the entire enterprise. It's a marathon, not a sprint, and it requires sustained leadership and continuous adaptation.
That truly highlights how the principles of scale and governance apply to almost any large-scale endeavor you might be involved in, from complex family projects to ambitious community initiatives or even national strategies. It's all about meticulous coordination, crystal clear communication, adapting your approach as you grow, and remembering that people and culture are the ultimate arbiters of success.
Couldn't agree more.
What an incredible journey we've had today. We've explored the transformative power of DevOps in bridging that historical, often frustrating gap between development and operations. We've journeyed from its origins and shared frustrations, through its foundational principles and cultural imperatives, touched upon its essential tools, learned how to measure its impact, navigated its common roadblocks, and even peered into its exciting future. It's been quite the tour.
To reinforce the absolute key takeaways from this deep dive, we've seen the indispensable importance of cultivating a truly shared culture that fosters trust, radical transparency, and deep collaboration, moving decisively beyond traditional silos. We've also highlighted the critical role of leveraging the right set of integrated tools to automate processes, enhance efficiency, and ensure reliability at every stage. And finally, the undeniable necessity of relying on actionable, quantitative metrics for success, ensuring that continuous improvement is always data-driven and results-oriented.
It's clear that both developers on the ground and technical management shaping strategy stand to gain truly significant advantages by adopting and, more importantly, genuinely embracing DevOps practices. This isn't just about getting code out faster. It's about a fundamental, holistic shift in how organizations conceive, build, and deliver value in a perpetually accelerating digital world.
Ultimately, the benefits are profound and far-reaching. Enhanced productivity across the entire organization, significantly faster delivery times for new features and essential bug fixes, and crucially, vastly improved team satisfaction and retention. When teams are truly empowered, collaborating effectively, and seeing the direct, tangible impact of their work, it creates a much more positive, innovative, and resilient environment for everyone involved.
So what does this all mean for you? As you consider the insights from this deep dive into DevOps, perhaps you're reflecting on how to apply these concepts in your own work or even your life.
This raises an important question. If the very core of DevOps is truly about breaking down barriers through collaboration, leveraging intelligent automation to reduce friction, and committing to relentless continuous improvement fueled by feedback, where else in your life or work could you actively bridge gaps, foster shared responsibility, and cultivate a culture of iterative growth no matter the field? Where could a blameless postmortem or a focus on lead time transform your personal projects or even how your family coordinates chores? The principles are universal if you look closely enough. Food for thought, wouldn't you say?
Absolutely, something for all of us to consider.